What is up, 7th grade? This is lesson 6. We're going to be talking about factors and divisibility today. First of all, factors. The factors of a number are the whole numbers that divide the number without a remainder. So it means you can take the number, divide it by that number, and you won't get any remainder. Or maybe you could think of it as numbers that multiply together to give you that number. If they multiply together to give you that number, then those numbers are factors. So let's list factors here of these numbers that I've given you, which are actually from your practice set. So what I'm going to do is I'm going to try to think of just two numbers that multiply together to give me 25. So I'm going to start at 1. So 1 times 25. 2, no. Other factors. 2 doesn't. 3 doesn't, 4 doesn't, 5. Yes, 5 times 5. So it's going to be all of our factors. So list the factors are just going to be 1, 5, and 25. Okay? 20, I'm going to skip to 24 over here. I can do 1 and 24. 2 and 12, 3 and 8, 4 times 6, and 5 doesn't go in there. So notice here, these numbers went up. I start at 1 and try all of them, and these numbers went down. And once they reach each other, the only number between here is 5. So this is going to be all of their factors. So if I want to write my answer now, I say 1, 2, 3, 4, 6, 8, 12, and 24. Okay? 23, we can kind of start off with the simple ones. I know that 1 and 23 will multiply. Let's say give me 23. Well, whenever I'm thinking about 2, that won't work. If I divide by 3, it gives me a remainder. 4 gives them a remainder. 5 gives a remainder. 6, 7, 8, 9, 10, 11. In fact, if you check all of those between there, they're all going to give you some kind of remainder. And so these are actually the only two here. It's just 1 and number 23, because 23 is a prime number. So the only factors there are just 1 and 23. Now that we kind of understand what factors are, let's talk about greatest common factors. And really, if you just look at the name, greatest means like biggest or largest. Common means something that both people have in common, or in this case numbers, something that both numbers have in common. And then factors. We already talked about factors up here. So just think about two numbers, you list all their factors. The biggest one that they both have is the GCF, the greatest common factor. So let's look at the number 18, and try to list all the factors of 18. It's going to have 1, 2. All right, 1 times 18, 2 times 9, 3 times 6. 4 does not fit into it, 5 does not, so 6, 9, and then 18. And then let's look at maybe the factors of 30, and there's going to be 1 times 30, 2 times 15, 3 times 10, 4 does not, 5 does, 5 times 6, okay, let's see, 3 times, so 10, 2 times 15, 1 times 30, okay, so now what I'm going to do is I'm just going to go through, I'm going to highlight ones that are in both. So notice they both have a 1, both have a 2, both have a 3, both have a 6, and I think that's it. So what I've done is I've highlighted all of the common ones. right? All the common ones. But it doesn't want just a common one, it wants the greatest common factor. So the greatest common factor of these two numbers is going to be 6. So the greatest common factor of 18 and 30 is 6. We'll say GCF equals 6. Alright, now if you want to test for divisibility, or if you want to find out if a number is, if you can take a number and divide by that, or is divisible by a number, here's some easy ones, or ways to check for a lot of the single digits. So first of all, if the last digit is even, so if the very last number, I don't know, maybe if I make one up here, 2, 3, 4, 5, 6. Since this last number is 6, that's even, so it would be divisible by 2. If the last two digits can be divided by 4, so if you can take 56 and divide by 4, it'd be divisible by 4. 8, if the last three digits can be divided by 8, so if I did like 4, 5, 6, it could be divided by 8, it would be. It's divisible by 5 if the last digit is either a 0 or a 5, so in this one I could easily say no, not that one. If the last digit is a 0, then it's divisible by 10, so again in this case no. 3, if the sum of the digits can be divided by 3, so if I added 2 plus 3 plus 4 plus 5 plus 6, if those added up to a number that could be divisible by 3, then it could be, then this number would be divisible by 3. 6, I'd have to check this one and this one. They'd both have to be true. Then it'd be divisible by 6. And then 9, if the sum of the digits, so if you add those up, would be divisible by 9. So let's see if we can try these. G says list the single digit divisors of this, or which numbers, single digit numbers, can be divided by this one, 1,356. So let's just go through and get some of the easy ones maybe. First of all, this last number is a 6, so I know it is even, so that means it's divisible by 2. So I'm just going to start listing them here as I figure them out. I know 1, right, it's a single digit, and I know 2. Okay, let's keep going up here. What about 3? 3 says if the sum of the digits can be divided by 3. So some of the digits, we're going to say, what is 1 plus 3 plus 5 plus 6? See how I got those numbers? 1, 3, 5, 6. So let's see, this is 4, this is 11. 4 plus 11 is equal to 15. Can 15 be divided by 3? Yes, because 15 divided by 3, it gives me 5. So then 3 checks out. What about 4? It says the last two digits can be divided by 4. So I'm going to think about 56. Can I divide that by 4? Well, 4 goes into 5 one time. That gives me 4. Subtract gives me 1. Bring down the 6. 4 times 4. 16. My remainder is 0. There. So it can be divided by 4? Yes, it can. So then I'm going to say 4. My numbers keep getting bigger here. For 5, it says if the last digit is 0 or 5. This is not a 0 or a 5, so I would not put 5. This is not a 0, so I would not put 10. 7 doesn't have a nice one. A nice way to check. 8, if the last 3 digits can be divided by 8, so we could check that one. So I'm going to say 3, 5, 6. Can that be divided by 8? Let's see. So it goes in that 4 times. Be 32. Remainder of 6. 6. I'm going to that 4 times. It's going to give me 32. But I'm going to end up with a remainder there of 4, right? You can hardly see it down there, but I get a remainder of 4. So 8 does not go into it. In this case, not 8. And then 9, and the sum of the digits is divisible by 9. Well, we already added the digits to get 15. 9 does not go into 15, so I'd not list 9 either. So that would be my answer right here. 1, 2, 3, and 4. H is right over here. It says the number 7,000 is divisible by which single-digit numbers? Well, I guess I should have checked for 7 over here. I never checked 7. So 1, 3, 5, 6. So going to 7, it goes into that 1 time. 7 gets me 6. Bring down the 5. Goes into that 9 times. 63. 2, 6. Goes in that 3 times. It's 21. 5. And so that's going to be my remainder. So it's not going to be 7. This one, however, an H, as we come over to H, 7,000, I see, is divisible by 7, right? Because that'd be 7 times 1,000. So I would know that one. So let's go here. 1 is definitely going to be 1. Let's check 2. If the last digit is even, is 0 an even number? Yes, it is. So I'm going to say 2. Coming down to 3. If the sum of the digits can be divided by 3, so it's going to be 7 plus 0 plus 0 plus 0. That's just equal to 7. So in this case, I would say not 3. Then let's check 4. If the last 2 digits can be divided by 4, so 0, 0 can be divided by 4. So I'm going to say 4. 5, the last digit is 0 or 5, so I can say 5. 6 is divisible by 2 and 3. 2 checked out, but 3 did not. So then I cannot say 6. 7 we already checked, right? 8, if the last 3 digits can be divided by that, last 2 digits are 0, so yes, can be divided by 8. And then 9, if the sum of the digits is divisible by 9, but 7 is not. So this would be all of my single digit numbers there. Alright, list all the common factors of 12 and 20. So let's list the factors of 12. That's going to be 1, 2, 3, 4, 6, and 12. Alright, 3 times 4, 2 times 6, 1 times 12. For 20, that is a 20 by the way, I'm going to have 1, 2, 3 doesn't, 4, 5, 6, 10, 20, 1 and 20, 2 and 10, 4 and 5. So common factors is going to be 1, 2, 4. 1, 2, and 4. So all of the common factors, which is what they asked, common factors are going to be 1, 2, and 4. Find the GCF, the greatest common factor of 24 and 40. So let's see if we can find all the factors of 24. 1, 2, I think we did this earlier. 3, 4. 5, no, 6. 8. 9, 10, 11, 12, and I think 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6, yeah. And then for 40, it's going to be 1, 2, bam. There's the rest of them. So I'm going to list for common ones here. 1, 2, 4, 8. And the biggest of those then is going to be the 8. So GCF is equal to 8. Your homework is going to be on page 43. Do all of them from lesson 6, all of them from lesson 5, and 15 more of your choice. Good luck.